Okay, let's talk about something incredible happening inside you, literally right this second. It's this hidden metabolic superpower that keeps you going, and in this explainer, we're going to dive deep into how it all works.
So let's start with a really interesting puzzle. Your brain, it's super demanding, right? It uses up like 20% of all your energy. And it has a favorite food, glucose. It pretty much only runs on glucose. But we don't eat 24/7. So how in the world does your brain get a constant drip of its essential fuel even when you're sleeping or haven't eaten in hours? And you know what? It's not just your brain. There's this whole team of what you could call glucose addicts in your body. We're talking red blood cells, parts of your kidneys. These guys are total sugar snobs. They can't use anything else, like fat, for fuel. So for them, getting a steady stream of glucose isn't just nice, it's absolutely critical for survival.
Okay, so how does your body deal with this? How does it avoid this potential energy crisis every time you skip a meal? Well, it doesn't just rely on its sugar savings account. That stuff runs out pretty fast. No, it has something way more clever, its very own internal sugar factory. And this amazing process is called gluconeogenesis.
And let's be super clear here. This is not just about breaking down stored sugar. Gluconeogenesis literally means making new glucose. We're talking about building brand new glucose molecules totally from scratch. The headquarters for this operation? Your liver. And the raw materials it uses, well, they're pretty ingenious.
All right, let's head down to the factory floor. Now, you might think, okay, making sugar is probably just the reverse of burning sugar, right? The process of burning it is called glycolysis. And yeah, you'd be mostly right. But here's the catch. There are 3 steps in that process that are like one-way streets. You just can't go backwards. So the body had to invent some really clever detours.
And this is where things get really cool. This is where you see just how smart our bodies are. Instead of trying to drive the wrong way up a one-way street, it builds these 3 specific bypasses. Each bypass has its own special enzyme to act like a guide, taking it around the roadblock. And that last bypass? Oh, that one's the most important. Think of it as the factory's shipping department. It's what lets the liver load up all that brand new glucose and send it out into the bloodstream to feed the brain and all those other hungry tissues.
Okay, so the assembly line is set up, the bypasses are working, but, a factory is just an empty building without raw materials. So where does the body get the parts to build new sugar when you're not eating any carbs? Simple. It recycles.
Seriously, your body is the ultimate recycler. It can grab the basic building blocks it needs from all over the place. For example, it can take lactate, that stuff that builds up in your muscles when you're working out hard. It can use amino acids from protein. It can even take the glycerol part that gets left behind when you burn fat for fuel. Nothing goes to waste.
And check this out. Here are 2 of the most elegant recycling systems you'll ever see. They're like these amazing shuttle services. You've got the Core Cycle, which is like a lactate taxi. It picks up lactate from your muscles, drives it over to the liver factory, waits for it to be converted back into glucose, and then drives that fresh fuel right back to the muscles. And the Glucose-Alanine cycle? It does a very similar thing, but with bits of protein, all while helping get rid of waste. It's just so efficient.
Okay, but think about this. Having a factory that can just pump out sugar is incredibly powerful, and also kind of dangerous. You definitely don't want that factory running full blast right after you've had a big meal and your blood sugar is already high. So, how does the body keep it under control?
It's all about hormonal managers giving simple go and stop orders. When you're fasting or working out, a hormone called glucagon comes along and basically yells, "Go! Fire up the factory!" But right after you eat, insulin shows up and acts like the boss, shouting, "Stop! Shut it down! We've got plenty of sugar coming in, let's just store it instead."
But wait, there's another layer of control here, and it's even smarter. Picture the main power switch for the whole factory. It won't even turn on unless a very specific key is put in the ignition. And that key? It's a molecule called acetyl-CoA. And acetyl-CoA only shows up when your body's actively burning fat for fuel. How brilliant is that? It means the sugar factory will only turn on if you're already burning fat. It's like the ultimate safety check to make sure you're not wasting energy.
So, we've toured the factory, we've seen the assembly line, the detours, the managers, the whole shebang. But let's bring this all back to you. Why does any of this matter? Why is it so important to understand what's happening under the hood?
Because at the end of the day, this process, gluconeogenesis, is the foundation of our metabolic flexibility. It's what keeps your brain from shutting down when you're fasting. It's the magic that turns muscle burn into more fuel during a workout. It's what allows us to run on a low-carb diet. Plain and simple, it is our body's amazing survival engine, letting us adapt and thrive no matter what we've eaten or haven't eaten. So yeah, this whole system is just fundamental to our health. It's this beautiful, precisely regulated masterpiece, designed to keep us perfectly balanced. Which leads to one last really big question. If this factory is such a lifesaver, what happens when its control panel breaks? What happens when those on and off switches stop working correctly? Well, that's when a system designed to save us can actually become a major problem, playing a central role in things like type 2 diabetes